All right, today we are going to move on and we are going to take a look at the notes for section 10-1. I'm not going to do the notes that are in your packet, so you're just going to need a blank notability or a sheet of paper to copy down these examples. All right, so we're going to start with some examples from the videos that you were supposed to watch on Friday. So the first one is x plus 1 equals 7. So we know in order to solve the equations, we always have to do the opposite or the inverse operations. So if I see plus 1 on the left side here, I've got to do minus 1 and minus 1. Remember, you have to do it to both sides of the equation. So that gives me x, because the minus 1 and the positive 1 goes away and becomes 0, equals 7 minus 1 is 6. So my answer is x equals 6. In the next example, x minus 3 equals negative 4. Here we have a minus 3. So we're going to do the opposite and add 3. So on the left side, I get x, but minus 3 and plus 3 is 0, so that goes away. And then negative 4 plus 3, again, if you owe me $4 and you pay me 3 back, you still owe me $1, so we're at negative 1. You can use your calculator to do that math. Unfortunately, you're going to have to use your phones if you don't have a calculator at home, but that's okay. Negative 4 plus 3 is just negative 1. All right, and the next problem, we don't see it, but there is a multiplication sign in the middle of negative 3 and x. So again, we want to do that inverse operation. The inverse of multiply is divide. So we're going to divide both sides by negative 3. Well, on the left side, negative 3 divided by negative 3 is 1. So that just gives me 1x or x. And then on the other side, negative 21 divided by negative 3 is a positive 7. When you multiply or divide, two negatives turns into a positive, or like I said, you can use your calculator and do the math that way. On the last review example from Friday, we've got x over 5 equals negative 2. So again, here we have, right here, we have division. So the opposite of division is multiplication. So I'm going to multiply both sides by 5. That way the 5 on top and the 5 in the denominator reduce, right? 5 divided by 5 is 1. So on the left side, I just get x. And then the other side, I get negative 10, right? A negative times a positive is always a negative. So those are problems that you should remember from middle school or from last year. And we've actually done some of these problems as we were cross-multiplying. So today we're going to take a look at what we call two-step equations, because you're not going to be able to do it in just one step like we did up above. Most of these will require two, and depending upon which way we do it, some of these will actually require a third step. All right, so the one thing we always want to do first is we want to get this variable all by itself. So I've got a negative 2 attached to an x. I want to get this by itself, which means I've got to move the minus 3. So just like we did up above, the opposite of minus 3 is plus 3. So my first step is to add 3 to both sides. So on the left side, I get negative 2x. Here, negative 3 and positive 3 ends up being 0. And on the other side, 11 plus 3 is 14. Now, the nice thing is, now this looks just like number 3 that we just did. The only difference is I have a multiplication sign, but I have a negative 2 in front. So the opposite of multiply is divide. So I'm going to divide both sides by negative 2. And this one gives me x equals 14 divided by 2 is a negative 7. Now, sometimes you will get decimals as answers. Sometimes you'll get whole numbers as answers. That's okay. But we should get nice decimals like 4.2, 3.7. You won't get a decimal that goes on forever, like 4.296354, etc. All right, so the one thing I don't like about number 6 is there's the fraction, right? Some of you are intimidated by fractions, but we're going to figure out an easy way to do this. Just like on the last problem, the first step is to get rid of that minus 5. We want to get this variable all by itself, so we need to move that negative 5 to the other side. So again, the way we do that is by doing the inverse operations or the opposite, so plus 5. So on the left side, I have 2 divided by 3x. The negative 5 and the positive 5 adds up to 0. And on the other side, careful, 5 plus 5 is 10. All right, so here's where there's a couple different ways to do this problem. I see divided by 3. Okay, so one of the things we can do is what's the opposite of divided by 3? I can multiply both sides by 3. So on the left side, my 3's go away because 3 divided by 3 is 1. And I'm left with this right here. I'm left with 2 times x. On the other side, I have 10 times 3, which is 30. And then my last step can be just like up above. We have multiply by 2, so we want to divide by 2. And 30 divided by 2 is 15. Now, there's another way to do this problem. Instead of multiplying by 3 and dividing by 2, we could take 2/3 x equals 10. So that step that we were at right here. And instead of multiplying by 3 and dividing by 2, we can multiply by what's called the reciprocal, which is 3/2, and multiply by the reciprocal, which is 3/2. We have to do it to both sides. So on the left side, on top, I get 6 divided by 6, right? Multiply the top, multiply the bottom. And 6 divided by 6 is 1, so we just get x. Over here on the top, we get 30, and then we have to divide by 2. So we end up getting 15. So again, we get the same answer. I personally like this way a little bit better because I think it's just a little bit easier and you don't have to work with fractions as much. But you are welcome to do it whichever way you like. Now with number 7, there's one thing that I don't like. I don't like the fact that the variables are on the right side and the numbers on the left side. So one of the properties of equations is I can just flip that. Whether I write 3 plus 2 equals 5 or 5 equals 3 plus 2, both of those are equal statements, right? They say basically the same thing. So we are able to flip these two sides and go 0.4x plus 5 equals 3.2. So all I did was reverse the sides, and then we can go ahead and solve. So now this looks very similar to number 5 that we did. I have a plus 5 on the left side. So I want to do minus 5 and minus 5. I'm going to get rid of that line there so it doesn't look like division. So we're going to go minus 5 and minus 5. So the downside here is we have some decimals, and that's okay. We're just going to go to our calculators, and we'll type in 3.2 minus 5. And that gives us negative 1.8 on this side. Okay, on the other side, we have our 0.4x. And again, the negative 5 and the positive 5 go away. They equal 0. And then our last step in this problem, since there is a multiplication sign there, we're going to do what we did before, and we're going to divide both sides by 0.04. So in our calculators, we're just going to take negative 1.8 and divide by 4. This time, I started with decimals. It shouldn't be surprising that my answer is decimals, but it's a nice decimal. I get negative 0.45. And that is a totally acceptable answer. Okay, it's a nice decimal. It's not a decimal that goes on forever. And in this case, negative 0.045 is okay. All right, so we're going to do number 8. Like I said, the way I like to do it, I think that involves less fractions. So again, the first thing to do is to get rid of that negative 6. To get rid of that negative 6, you have to add 6, or that minus 6. We've got to add 6 to both sides. So I get 1/4 x. Negative 6 and positive 6, or minus 6 and plus 6 becomes 0, so that goes away. And then 2 plus 6 is 8. Just like we did on the example 6, I've got it divided by 4, so I'm going to multiply both sides by 4. Well, the nice thing here is I get 1x, right, because the 4 divided by 4 goes away. So I am left with 1x equals 32. Now, there are some of you that are going to divide both sides by 1. And 32 divided by 1 is just 32, and that's totally acceptable. However, one of the things that you probably remember from middle school is that 1x is the same as just x. So dividing by 1 doesn't really change anything, so we could just say x equals 32. But if you want to divide both sides by 1, because that's what we do if there's a 2 or a 3 or a 4 there, that, again, is totally acceptable. All right, we've got 2 more examples to do. And they're very similar to the ones we've done up above. So again, here I have a plus 3. So what do we need to do? We need to do minus 3. So I'm going to subtract 3 from both sides. So on the left side, I have negative 2 divided by 5 times x. 3 and minus 3 goes to 0, so that goes away. And then if you owe me $2 and you borrow 3 more, now you owe me $5. So it's negative 5. If you need to use your calculator, that's okay too. All right, last 2 steps. Again, we have a divided by 5, so I want to do the opposite, and I want to multiply both sides by 5. So 5 divided by 5 gives me 1, so it goes away. So on the left side, I'm left with negative 2 times x, and on the right side, I get negative 25. All right, so again, now we have multiplication, and we have to do the opposite. So I'm going to take both sides, and I'm going to divide those by negative 2. So the negative 2's divide to give me 1. So I just get 1x, or like we said, x. And then negative 25 divided by negative 2 is a positive 12.5. Again, it's a decimal, but it's a nice decimal. And we're okay with nice decimals. All right, last example for today. Again, I don't like the way that this is written, so I'm going to take these two sides and I'm going to switch them. So I'm going to do 10 minus 2x equals 12. Now, this one's written a little bit differently, so we've got to be really careful. Remember, our whole goal is to get the minus 2x by itself. We want to get x by itself, but first we've got to get the negative 2x or the minus 2x by itself. So what we need to move to the other side is that 10, or just the number. So since it's a positive 10, I'm going to do minus 10 to both sides. So here I get 10 minus 10, which is 0. So I'm just left with negative 2 times x, or negative 2x. And then 12 minus 10 is 2. Okay, again, this is all about doing the inverse operation, or the opposite of what you would think. So the opposite of multiplication is divide. So I'm going to divide both sides by negative 2. So on this side, negative 2 divided by negative 2 is 1. So 1x is the same as x. And then over here, 2 divided by negative 2 is negative 1. And there's my final answer. All right, so you have a worksheet on Schoology, and I've also sent it via the email, and it's an attachment. So I would like you to put that worksheet into Notability, and then we will go over that worksheet when we see each other on Wednesday. Thanks, and stay warm.